All right, so we're going to begin with Unit 2, which the good news is Unit 2 means we can use calculators. Yay! The bad news is if you don't know how to do things without a calculator doesn't really help that much because you have to put it into the calculator, right? So a calculator is only as good as you are. If you cannot do math without a calculator, it is not really that helpful to have one. I want to go over two things that I noticed on people's tests and quiz that you guys are still carrying over and having issues on. So just really quickly, maybe. Really quickly, I want to talk about multiplication with decimals and addition and subtraction with decimals because people have made the same mistake many, many, many times on the test and quiz. And so if you have a problem like this, 5 3.2, what kind of math are you doing? Multiplication. So we're multiplying with a decimal, right? All right, I'm looking at this. I don't like the way that's set up. How do I set up usually a multiplication with decimals problem? Do I do it horizontally or do I do it vertically usually? Yeah, usually you want to do it vertically. So I'm going to put the 3.2 on top because it has more digits, and I'm going to put the 5 on the bottom. That's up to you. You can do it however you want to do it. I've also seen people doing this, 3.2 times 5.0, which is fine if you want to do it like that. It just you have to do something a little bit differently at the end. So taking a look at this, how do I do this? 5 times 2 is 10. Carry the 1. 5 times 3 is 16. Okay, now how do I know where my decimal goes? Jesse, why do I only move it over once here? There is only one number behind the decimal. I move it once. So I move it once and I end up with what? 16.0. which is the same as just 16. Okay, this is not wrong. Leave it like that if you want to. That's fine. Okay, but you move it over the number of times that there's digits here. So how many times would I move this one over? 2. Why? Good. There's a 2 behind the decimal and there's a 0 behind the decimal. And the reason that you still get the same answer is because what did you basically add here? Like no value, but you changed the place value, right? So you moved it over one more spot. So you end up getting 0, 0. Then we have a placeholder. 5 times 2 is 10, 16. So we end up with 1600. That's why you move it over twice, which again, 16.00 is the same as 16. So both of your answers are the same there, okay? So for those of you guys that are consistently making this mistake on tests and quizzes, keep in mind, again, yes, a calculator is going to help you with this, but this is stuff that you do need to know, all right? Same thing goes when you're adding or subtracting with decimals. For instance, you guys had a problem like this, like 5 on your test and on your quiz. If you want to do this as a fraction, you can. A lot of you guys were doing them as decimals, which is totally fine. What decimal does this become? 0.5. So now it's 0.5 minus 5. Okay, how do I set that up? Jesse? Okay, the 5 is going to go on top because 5 is the bigger number. So I'm going to put 5 on top, and I'm going to put 0.5 on the bottom. But where does the 5 go? To the right. Because the decimals in addition and subtraction, what do they have to do? They have to line up. So in addition and subtraction, they have to line up, which means if I'm going to subtract this, I need to basically turn this into 5.0. So 5.0 minus 0.5, which is ultimately going to give me what? 4.5, because I just bring my decimal straight down. Go back up to the problem. Which is bigger? 5, which is positive or negative? Negative, so your answer should be negative. Remember, a minus sign acts just like a negative. So when I say it's negative, it's because of the minus sign. It acts just like a negative sign. So be really careful with this one. Be really careful when you're adding and subtracting. Again, is calculator going to leave some of that for you? Absolutely. Okay, but you should still know how to do it. Jesse? What? Like if you wanted to do it like a fraction? How would I do 1/2 minus 5 if I wanted to do it like a fraction? Somebody who did them like a fraction, David, what do you have to do first? Put a 5 over 1. Okay, what do we have to do next? Before you can add or subtract fractions, you need, Dejne? Like denominators. In this case, what's my like denominator going to be? 2. Did I change this one at all? So does this change? No. Okay. Did I change this one? Yes. What did I multiply it by? 2. What do I multiply this by then? Which gives me? All right. Now I've just got to do 1 minus 10, which is positive or negative 9. Good. Over 2. And if I do that division, that ends up giving me 4.5. But like I've told most of you, leave it like this. Be as lazy as you want to be once you get to this point. Okay, you don't need to do the division. You can leave it as an improper fraction. These are the same exact answers. That was like a really good little fraction subtraction army that you guys just became. It was good work. Okay, so common denominators. I don't think one is like necessarily easier than the other. Once you can use a calculator, I think it's easier to convert it to a decimal. But it's up to you guys how you want to do it. Okay? All right, keep in mind you can't forget everything you learned. Okay, so what are inverse operations? What are inverse operations? That's a fancy way of saying what, Jessica? Opposite. What's an operation? Besides like in a hospital when you have surgery. But in math, what are the operations? Elijah? They're in equations, yes. Think about order of operations. Emmanuel? Division. Good. So the 4 basic operators, plus, minus, subtract, or plus, minus, multiply, divide, those are what we're talking about here. Of course, it also includes parentheses, exponents, all of that. But what we're focused on is those 4 basic operators. Hello? Hey. Okay. I can. All right. Alfonso, you're sprung. I would keep it. I would check out my YouTube channel for this video later. All right. So inverse operations are going to be opposite operations. So for instance, if I say addition, what's the inverse operation of addition? Andy, why? Because that's the opposite of addition. Good. It does the opposite, right? So then what's the inverse of division? Multiplication. What's the inverse of an exponent? Square root. Very good. What's the inverse of, that might be all I have. The inverse of an exponent of 2 is square root. Cube root would be of cube. Quad root isn't a thing, but it is, we don't call it that, but you could do it. All right, so inverse operations are just opposite operations. All of algebra is just doing opposite operations, right? So what we're doing now is we're moving from chapter 1, where we were just doing basic kind of pre-algebra stuff, to now we're moving into actual Algebra 1 stuff. And again, you guys have probably seen a lot of this before. We're just going to delve a little bit deeper into it. So inverse operations is everything that we're doing in algebra. So remember that Elijah said with operations, we're talking about equations, right? And what makes something an equation? It's a problem with a what? With an operation, and it has a solution, so it has to have an equal sign. So we're talking about things with equal signs. If it doesn't have an equal sign, it's just an expression, right? We can't solve it. We can simplify it, but we can't solve it. So for instance, is an algebraic equation, because there's an equal sign. And when we're talking about algebraic equations, the key to an equal sign is an equal sign tells you what? What does an equal sign tell you? Elijah? Okay, maybe. But what if I had this over here? Like, it doesn't necessarily just have to be one number.
Oh, that's when that would be more of the ones where you can't really solve them because you have to take away 2x from that side.
Oh, I could solve this. It's just going to be a little more work, right? Yeah. Jessica? Okay, very good. So an equal sign is basically a shorthand way of writing this is the same as on the left side and the right side. This is the same as. I'm going to erase this green stuff just to keep it a little bit simpler. But I'm looking at that and I'm thinking, well, that does not look the same to me. Like if I asked a first grader, is this the same as this? What would they say? No, why not? It doesn't look the same at all, right? Like this does not look anything like this, but an equal sign tells you that they are the same. And Emmanuel, you said that this has an X in it, right? So how does that X allow you to make them the same? How does that X allow you to say this is equal to 12? What does that X do? What's special about an X or a Y or a Q or whatever you want it to be? What's special about the letters that we use in algebra? You can put any number you want in them, which means you can put whatever number is in there that's going to make this side equal to what? 12. And algebra is all about just answering one question. What's that number? Right? What is the number that I can put in here to make this equal to this? Now, you guys have seen really basic ones, like x plus 3 equals 9. Well, what is that? 6, right? That's a really basic algebraic equation. Dejane?
So, like, you could basically just subtract the number behind the equal sign.
Exactly, because that is an inverse operation. Very good. So what you're doing in algebra is we're going from here, then we're going to start looking at equations that are a little bit harder, and then we're going to start looking at equations that are way harder. But ultimately, the goal of algebra is always to do what? What can I put in for x that's going to make the two sides of this equation balance? And a lot of times we think about balance like a scale. How many of you guys have seen those scales that like you can put rocks on like in science classes or science labs? Okay, so what happens if you take a rock off one side? Yeah, it gets off kilter, right? And in algebra, we always want our scales to be even. So that's why we always say, just like with a fraction, if you do something to the left side, what do you have to do to the right? The same thing, exactly. Just like with a fraction, if you do something to the bottom, you have to do the same thing to the top, exactly. So we're worried about balance and we're worried about scales. Okay, so we already answered these. We said the operation that's inverse of addition is subtraction and the inverse of subtraction is addition. So then what Dejane said is answering this question. So how can we then solve this algebraic equation, right? And your minus 5 on both sides is because the 5 is what kind of number? It's a positive. So to get rid of that positive, and when I say get rid of, why do I want to get rid of it? Because it's with the variable, and what do I need to happen with my variable? I need to get it alone. Because again, the question I'm always trying to answer is, what is x? What can x be? And to figure out what x is, I need to get it by itself. So Ray says, I want to get rid of a positive 5. I'm going to do that with a minus 5. If I do it here, though, where else do I have to do it? On the other side of the equal sign. How many of you guys, when you first started doing this, drew a line through your equal sign? So not that many of you. Why did you do that? If you did that, why did you do that? Zulema? To separate them. Because I know then that if I do it here, I have to do it on the other side of the wall. I don't subtract it from here. Why not? Well, one, I can't do it, right? Because it's x and 5, and I can't subtract those. But also, if I subtract 2 5s from one side of the wall, but nothing over here, am I in balance? No. So I'm not going to ask that you draw this wall, but mentally, keep in mind an equal sign is like drawing that wall for you. So I know if I do a minus 5 here, I'm going to do it here. And then what happens to these? Yeah, they go away. They're gone because they're inverses of each other, so they just disappear. Really, they become what number? 0. But do we need to write that 0? No, okay? So some people don't like saying canceling out. Some people think you have to keep in mind it equals 0. Okay, good. I'm just going to shortcut this. We're not going to write 0. But that technically equals 0. Okay, so then what's left?
7 minus 5.
7 minus 5, which is 2. And that equals, why don't I have anything else on this side anymore? Because it's gone. We got rid of it. It was a 0, and we don't need to write it, right? Because it's just like a placeholder. So x equals 2. How could I go back and check? Plug that back in with addition. What's 5 plus 2? 7. Okay? That is a very like slow process of what we've been doing. How many of you guys have done this before? Good, okay. All right, what would I do here? I'm going to do on this side, I'm going to say, and if I do it here, other side of the equal sign. So again, imaginary wall on both sides. What happens to these two? They're gone. And what do I have left here? Just an x. And then what do I have over here? 9. How can I check that? Plug it back in. What's 9 minus 6? 3. So did that work? Yes. I'm not going to require that you write out your checking. I think it's a good idea to go back and check your work, but I'm not going to require like that you write out the steps showing me like 9 minus 6 equals 3. I am going to recommend if you get them wrong all the time that you're going to start trying to do that. Hang on. I want to go back and look at one more. Okay. What's different here? What's on the other side? The x is in a different spot, right? It's not first. Okay, so what am I trying to get rid of? The 5. What kind of 5 is it? It's a positive. So how would I get rid of it? Minus. So even though this is a subtraction problem, what am I trying to get rid of? The positive 5. So if I subtract 5 over there, then I have to do that over here, right? All right, what happens to these two? What do I have left? Negative x. Very good. Negative x. Okay, what's 2 minus 5? Good. That's not an answer, though, because I need x by itself. So what do I do now? Multiply it by -1 or divide by -1, or, shortcut, if this one's negative and you want to make it positive, just get rid of the sign and then change the sign over here, okay? So a negative x to become a positive x means that this -3 becomes a positive 3. That's it, okay? That's the shortcut of what you're doing when you're multiplying by -1 or dividing by -1, all right? So just flip your signs. If it were like this, then if you made this a positive x, this would become what kind of 3? Negative. Yep, so you're just flipping your signs. If you flip one sign, you've got to flip the other. All right? This is more often than not where people screw up on a problem where the x is in the second place, because they forget that it's a negative x, not a positive x. All right? Okay, do these 10. Okay, so does anything about the process change if I put a fraction or a decimal in there? No, nothing about the process changes. We still do it exactly the same way, except it has a fraction or a decimal, which automatically means that you guys see it and you're like, oh my God, this is so much harder. No, it's not. It just has a fraction or a decimal in it. So as a reminder, because we went through a couple problems before, bless you, if I have a decimal here, what do I want to do with my 3? Make it a decimal number. And since this one goes to 2 places, what should I make this one? 2 places. So make it 3.00. Why do we do that? David? So they line up, right? Because if they don't line up, then you guys make goofy mistakes all the time, like everyone just did on their test when they put 0.3 for the second one. All right? So if you do not make it into something that's going to line up, you will forget that you need to line it up. So it's going to line up now because it has 2 decimals here and 2 decimals here. So then what do I do to get rid of this plus 0.75? Negative 0.75. And where else do I do that? Minus 0.75. What happens with this one? Those are gone. So what do I have left? X equals. Okay, now I can't do 0, 0, so I have to borrow. This becomes a, and this becomes a 10. 10 minus 5 is, 9 minus 7 is, and 2 minus 0 is, okay, 225. Can you do that on a calculator? Absolutely. Okay? So again, a calculator is going to help you, but if you don't understand the algebra that you need to do to begin with, a calculator doesn't do you any good. Okay? Now, they're over there in those yellow bins. All right? You will probably want them for the next practice. I do recommend writing the problem out. Like, I know you guys did a lot of the last ones in your head. Why were those easier to do in your heads? Yeah, they weren't fractions. It's not that fractions are harder, but is there more to keep track of? Yes, there is definitely more to keep track of. Okay, so I'm going to recommend that you actually write out what work you're doing. If you then want to plug the work into your calculator, fine, like that's fine, but just try to write it out. And I'll show you guys how to put a fraction into these calculators in case you don't know. Okay, all right, so what would I do here? I still need like denominators, but before I do that, what operation am I going to do? It's a minus 2/3, so I'm going to add. Okay, plus 2/3, plus 2/3. What happens here? Those are gone. So what do I have left on the left side? X equals. Okay, now, Dejane, I need like denominators. This is set up really nicely for me. I like them vertically. What's a like denominator between 8 and 3, Elijah? Good, 24. How do I figure out what my numerators are? Yeah, whatever you multiplied it by, right? What do I multiply 8 by?
3.
So what do I do this by? And that gives me,
15.
good. Down here?
8. 16.
Good. If you don't need to write those out, don't. All right? If you can do that in your head, do it. But if you have trouble with it in your head, don't. All right, now I'm going to do 15 plus 16, which is 31. Yeah, that seems right. 31 over 24. I'm lazy. Do I need to do anything else? No. Okay? If you do it on a calculator, is it going to give you an answer like this? No, it's probably going to turn it into a decimal, or it'll turn it into a mixed number. One of those two things. Okay? So one of those two things will happen. But keep in mind, if you do it on paper, I am more than fine with improper fractions. I like them. I think they're nice. Okay? So it's less work. Keep it at less work. If you want to do it, by all means, do whatever you want. If you want to do 31 divided by 24, have at it. Okay? I'm not going to, so I wouldn't if I were you. But you can do whatever you want. The choice is yours. All right, before you move, I have a couple things I want to say. Some people, and I don't think you should be, but some people just really hate fractions, right? So what can you always do with a fraction if you are the type of person who hates fractions? David? Well, but I hate fractions, David. I don't want to deal with a fraction. So what could I do?
Change it into a decimal.
Make it into a decimal. Let's go over some common decimals. Half is 0.5. 1/4 is 0.25. 3/4 is 0.75. I think that's everything up here. Okay. All right.